Hello and welcome to this tutorial on basics of embedded C. In this tutorial, we'll discuss about programming languages in general, some elementary concepts in programming like variables, data types and loop constructs. The main aim of this tutorial is to serve as a refresher, assuming that you may have had some programming experience before. If not, along with these tutorials, you can refer to a more detailed and a formal tutorial on programming in C which has been uploaded on the portal. With that being said, let's start. So we'll see what is a computer program. A computer program is a set of instructions that can be executed by a computer. In layman terms, you can refer to a computer program as a sequence of logical steps that can be performed by a computer to accomplish a certain task. Let's take a trivial example of adding two numbers. As you can see here, I have divided this task of adding two numbers into a sequence of logical steps that can be followed by a computer. Now, how these steps are written down and conveyed to the computer is defined by something which we call programming languages. Just like in case of English language, we follow a certain syntax, that is the arrangement of words and phrases in order to form a meaningful sentence. Similarly, in programming languages, we have to adhere to a syntax while writing your program. Now, coming to embedded C is an extension of your conventional C language and uses most of the syntax and semantics that are used in C. Embedded C is particularly written for microcontroller based applications. Next, we'll see what are variables and how are they used in programming. So, programs require data as input or may output some data. If we refer to our previous example of adding two numbers, the computer required some space to store those two numbers and also the result of the addition. A computer uses the locations in its memory to store this data. Every memory location has a unique address which is used to identify that particular location inside a computer's memory. So in order to store some data, I need to know the address of that particular memory location. This is where variables step in. Variables can act as storage containers for data. From our previous discussion, we concluded that in order to store data, some memory locations are required and we need to know the address of those locations. So instead of knowing the actual memory address, we can substitute it with user-defined names which are called as variables. Now let us look at an example of variable and its syntax. As you can see here, I have declared a variable called count, which is user-defined. Preceded it with something called as data type. Now, data type refers to the nature of the data to be stored. So, in this case, the variable count stores integer values, and I have stored the number 9 in the variable count. If you see closely, the variable count now points to the memory location where the number 9 is stored. This is how we can use variables inside an embedded C program or in programming for general. Now we'll look at some examples of variables and how to use them in embedded C program. Here are some examples of variables and fundamental data types that are used in embedded C. We have written these examples in the editor of AVR Studio 4.17 IDE. we recommend you to use this IDE during the course of task-based training to write and develop embedded C applications. Okay, so let us now look at the first example of an integer variable. As you can see from this statement, the keyword int is used to denote an integer variable named count. And accordingly, I am defining a value, or rather storing a value of 5 in this variable. This statement right here is called or is referred to as variable definition as per C nomenclature. The previous statement is called as variable declaration. The main difference between these two statements is that in this case, I am only telling the compiler the name of the variable and its type, whereas in this case, I am defining the value of that variable. I can even define and declare the variable at the same instant, like in this case. Coming to the size of an integer variable. Now, the size refers to the space an integer variable will consume in my computer's memory. This size depends on the compiler I am using. In this case, an integer variable will consume 16 bits or 2 bytes. Next, we'll look at the data type float. Float is used to store decimal numbers. Here I have declared and defined a variable named distance having a float data type. A float variable is distinguished by a keyword called float, and I am storing a decimal number 5.5 in this float variable. In case of float, a maximum of 6 digits can be stored after the decimal point. Coming to the memory size required to store a float variable. A float variable requires 4 bytes or 32 bits of memory in my computer's RAM to be stored. Now, this requirement or this extra requirement as opposed to an integer variable is due to these 6 digits after the decimal point. Now, let us look at the character data type. Character data type is used to store ASCII values. Now, what are ASCII values and where they are used? All the alphanumeric characters along with the special symbols like hash, space, the $sign that you see on your computer monitor is nothing but a set of integer values which, when given to your video processing circuitry, will display those characters. In a nutshell, every character has a unique integer value which is used to represent it. So as far as the CPU of your computer is concerned, these characters are nothing but a bunch of integer values. Now, the most standard way of representing these characters by integer values is the ASCII set. ASCII stands for American Standard Code for Information Interchange. This character variable is used to store these ASCII values. As you can see in this example, I am declaring a character variable named output. A character variable is denoted by this keyword char. Next, I am storing the letter lowercase y in this character variable. You'll notice this single quotation marks. These single quotation marks indicate the ASCII value of the letter y. So, in this case, I am actually storing the number 121 in my character variable output. Now, this character data type will be very useful while displaying or working with LCDs. From our discussion about the fundamental data types in embedded C, it is quite evident that each data type uses different memory size. Now, the main reason to include this is to ensure efficient utilization of the available memory, which is always a constraint as far as embedded systems is concerned. For an example, if I wish to store only integer values, there is no need to declare a float variable, thereby wasting extra 16 bits, which are very precious. One more peculiar thing that you will notice is the semicolon. Now, the semicolon in C is used as a statement terminator, indicating the compiler the end of a particular statement, which helps in passing the code while compiling. Next, we'll look at loops.